SwayamPrabha. Digital India. Educated India.
So, we have seen these. We use the standard differential equation of A, that is adoption rate. AR is nothing but dA by dt, which is A is adopters, and we solve to get the equation in logarithm of AT by PT minus logarithm of A naught by P naught is C into I into T. It can be further rearranged to give equation 3 as well as equation 4. This equation 4 is also called as a logistic model, a special case of which will be a sigmoid curve. So, if you come across that, it's a similar kind of model that we have seen. When does max adoption of sales rate occur? We figured that also. Now let us get back to our example, and we want to estimate the parameters. The first approach is to use equation 2 to estimate the parameters. We are going to do log transformation and linear regression to estimate the parameters. Since only C into I can be estimated, C and I separately cannot be estimated, we do not have enough data for that. So, we will just take the product and estimate it. So, before we go to the spreadsheet, let us just quickly come back to our notes to see what is it that we are going to estimate. In approach 1, we are going to estimate parameters from equation number 2. We know that logarithm of A by n minus AT is equal to logarithm of A naught by n minus A naught plus C into I into T, or logarithm of AT by PT is logarithm of A naught by P naught plus C into I into T. Again, note that PT is n minus AT, right. So, that is why you have this. This is in linear regression form. The form of y equal to A plus Bx. C is a constant, which is nothing but this. So, B is nothing but C into T, X is nothing but your C into I, rather B is C into I, X is your T, right. So, that is what we have. So, this is your Y variable, this is your A, C into I is your B, and T is your X, and we can get the product. So, if you have these two data values, we can plot a simple linear regression of it to find the intercept and the slope, right. That is precisely what we are going to do. This was the form. Then I am going to use linear regression to estimate A and B. Okay. Sorry for confusion, let us just call it small a. We already have capital A in use, so just avoid confusion. So, then we will use regression to do that. That is precisely what we are going to do. Let us go back to our spreadsheet. Okay. Let's go up to the spreadsheet. Before taking logarithm, we need to figure out what is the potential adapter. So, for the first approach 1, you can see on the right side of your spreadsheet, that is from column M onwards. First is step 4, calculate total population n. So, we need to guess some value of n. So, for that you can just check what has been the total cumulative sales so far. It says 7900. So, that means that is the total number of adopters that has been. So, any number greater than that is should be sufficient. So, for basic purposes let us just assume that it is 7900, just bold. So, you can just write the number as 7900 as the total population n. Now, if you approach here to column H, we need to compute the PT, so you get n minus 80. The formula needs a little update. It's $O $6 minus F2 because total n does not change. So, update the column, update the formula minus the actual sales 80. Using that we can compute our values of P. So, do that, drag it downwards till row 29. So, you should see that the value of P goes in the opposite direction as A, which is as expected, it goes from 7900 to 0. So, once you do that, we need our Y column, that is nothing but logarithm of A by P. Sample has already been calculated for us, logarithm of A divided by P. So, I am going to simply drag that column all the way to row number 28. So, I have done till step 6. In our approach we have done till step 6. Now, step 7 is to plot column I versus time. So, to do that, I hope all of you know how to plot it in Excel. Select the column I, click insert, click a scatter plot, as soon as you click a scatter plot you will get this, right click, select data, because we want to set the x axis data. X axis should be the time that series that we have got, right. By default you just take 1 2 3 4, we just select the go to series 1, select x values, the x values are 0.25 to 0.65 in column D. You will get a curve like this or a plot like this. You can move the plot down so it does not hide any of the figures or text in the text you have. And to fit a regression, it is quite simple in Excel. You can just right click the data series or any of the dots, right click it, click add trend line. By default it will be linear, select linear, display equation on chart, display R squared value on the chart, and you are done. So, this graph you can see here, we just selected both the columns, other value as time, we selected time as the x axis and we selected logarithm of A by P as the y axis values, we plotted them and we fit a regression line, linear regression, and we got a equation y equal to 1.5509 x minus 5.2674 with R squared of 0.94. So, let us write these values. So, the intercept is minus 5.2674, the slope Ci is 1.5509, R square is 0.94554. Even if you did not get it, you can copy the values that I am just typing here into the boxes that has been provided for you in column O, step 8. So, we got the intercept, slope as well as R squared values. So, from this the intercept is nothing but logarithm of A naught by P naught, right. So, we need to calculate A naught. How will we do that? Logarithm of A naught by P naught is equal to minus 5.267, and P naught value, what is the initial value of P? Just go up and see. Initial value of P is 7900, that is also given. So, value of A naught will be e power the intercept value into P naught, which is nothing but total population n. So, I just wrote equal to exp of O11 multiplied by O6. So, A naught comes to 40.7. So, that is initial number of adapters, it says is 40.7. So, as soon as you enter the values, you will see that in column K, the first two rows are filled. Now, we are moving to step 10. Step 10 says use equation 4 to complete fitted A. Now, I need to compute the sequence for A, and for A we derived the equation 4, which gives expression for A, which is nothing but shown here in this formula, n divided by 1 plus what is it, n minus A naught by A naught into e power minus C into I into T, which is what is coded for you. So, if we drag this, since now this AT is just dependent on time t, you can drag it even beyond 6.5, because we are just now using it to estimate the value. So, we are actually doing a little bit of forecasting. So, you can drag the second row downwards. Okay. So, this gives our fitted cumulative sales A. After completing column K, if you scroll down, you will see two graphs. The blue line corresponds to the actual data and the red line corresponds to the fitted data. It is an approximate fit. So, let us see how the fitted data corresponds to the actual sales data. That is step number 11, computed fitted sales per year. So, if you drag the formula for that all the way down, and go beyond. So, you will see this graph that appears x axis here. I am just, all the formulas are pre-filled. So, if you fill the basic values and drag it, you should get this curve. So, red curve gives the fitted curve, which is kind of an approximation for this given data. So, to get this curve, you need to fill these values in column O. You can take a quick look at it, you can fill these values and just drag the formula, it should work for you. Okay. Just pausing for a minute so that you can see, enter it. Intercept is minus 5.26, slope CI is 1.55, A naught is 40.7. Even if you do not know the formula, you can just type the number. Now, let us interpret this graph. Idea is not to just fit some curve, it should be an accurate fit. You can observe that initially the model seems to be underestimating here. Here it seems a reasonable fit. Peak it seems to overestimate, it seems to overestimate the peak and again starts underestimating the tail, or rather the second half of the curve. It seems to underestimate heavily here, it seems to overestimate it here. The result is this cumulative graph, which seems to kind of underestimate in the starting period and then overestimate here, and towards the end kind of reach it much earlier than this can do. This is figure we have. Instead of this is one approach. See, this approach is heavily dependent on your initial value of population. So, instead of this initial value of population, we can use any other values. We could have put any other values of C and I to see what happens, right? Or can we use that existing equation number 4 to directly solve this, which is what we are going to do in approach 2. In approach 2, we are directly going to use equation number 4 and we are going to choose parameters n, a naught, c into I, so that the least square error is minimized. You can do it in a trial and error method, we do not need to convert into regression model. We are trying to do a logarithmic regression, and if it is not that great, we can try to see how we can do that. So, in your same Excel spreadsheet, go to sheet number 2, okay. Again the first up to column D is exactly the same as the old one we had. The sales data, let it convert into B2 by 4, drag the sales data. Now, some values in column O, you will see it is already pre-filled for you, that is it 7900, slope is 1.5, A naught is 40. We do not know how we got it, assume we got it, we can always fit this curve AT, right, which is what, let us complete the cumulative sales and the fitted equation, we know the equation. So, I can just simply drag the equation to the end and I can compute the square error for it. I am going to drag the fitted sales also along with that. Now you can see that if you are going to change this initial population, I am just going to focus on column O, and if I change that initial population, suppose into 7900, I put 8000, you will observe that the sum of squared error will change. You can just take any number 81 or 7950, the square error changes, and if A naught changes from 40 to 45, again square error changes. You just drag all the formulas that is written except for column E, where that should be the sales value divided by 4, not time divided by 4. So, if I change those values, I am going to get arbitrary fits. What is that fit? I request you to go back to sheet 1, and if you scroll, I just put everything in one graph, the green line. So, this green line will keep shifting for whatever values I am going to enter in the sheet number 2, but I want the best fit. So, to do that, we can actually use the optimization solver to fit it, where I minimize the mean square error. So, to do that, you need to go to tools, Excel add-in, include the solver. So, if you have it, then you go to tools. If you do not have it, go to Excel add-in, add the solver, go to solver, set the objective as 11. I have given what is to be entered by changing all these 3 values n, ci and a naught. Again, what is to be entered, I have written it here, right here, I have entered it here, what is to be entered, and that is it. You do not need to worry about any constraints, just solve it, keep solver solution, okay. Okay, oops, I maximized it, sorry, data, tools, solver, minimize it, yes, minimize the mean square error by changing the cells, solve it, okay. I need to set it at initial values, slope is 55, data, solver, okay. Once you solve it, in this case we got a estimated total population of 8075 with a slope of 1.24 and A naught as 89, and automatically you would have seen that all your H and I's would have changed and K's. So, we can simply go to sheet 1 and observe that I am getting another curve here which is green curve, which seems to be a slightly better fit than the previous case, but still it seems to be overestimating in the start. Peak seems to be much better and some underestimation is happening in the second half of the curve, but not as much as the previous one. So, this seems to be a better fit, and here when you put the cumulative sales, you find that it seems to be much better fit with your blue line and the green line. So now the drawbacks of this diffusion model is that there has to be some initial number of adopters. So, to get over that assumption, we have to update our model in something called as a Bass diffusion model named after the person Bass, which we will look at it in next class. But for a given diffusion model, I hope you found out how to fit based on the existing data, and in the columns I have given what are the steps to be. If you follow that, you should be able to get this answers. Thank you.